All right, section 9.1, we are looking at another way of solving a system of equations. This one utilizes something called an augmented matrix. So we're going to look at what that means. We're going to look at what kind of row operations we're allowed to use to manipulate that augmented matrix. And we're going to start today talking about something called Gaussian elimination. And then next week when we come back, we'll look at the Gauss-Jordan elimination process. All right, so a couple definitions. A square matrix. We've talked about this a little bit already. A square matrix is one where the number of rows and columns match. So we're looking at 3 by 3s, 2 by 2s. Okay, that would be a square matrix, a 2 by 2 matrix. The main diagonal is the one that starts in the upper left corner and it continues to the lower right. So in my example here, the main diagonal would be this. And our last definition, an augmented matrix is a matrix that represents a system of equations. When we looked at solving a system before, and I don't want you to write this down because we're not doing this today, but we used to set up a coefficient matrix, then we had a variable matrix, right, with our x, y, and z's in it, and we had it equaling our constants. Remember that? And we put this in as matrix A, this is matrix B in our calculator, and to find x, we did the inverse of A times B. Remember that process? In doing that, we took a system of equations, we converted it to a matrix equation, and we solved that matrix equation. That's not quite what we're doing today. We are going to set up an augmented matrix, and it's going to resemble more closely what we did back in Chapter 8, where we solved a system by adding and multiplying, that kind of idea. Okay? So, an augmented matrix for this. We have all of the coefficients on the left, and then most books, not every book, but most books put a dotted line, and then in the final column, they put the constants. So for this example, my numbers would look like this. Our coefficient for x is 1. We have a coefficient of 3 for y. In this first equation, we have no z's, so my z coefficient would be 0, and my constant would be 9. Okay? The second row, I have no x's. The coefficient for y is -1. For z, it's 4, and my constant is -2. And my last row, I have a coefficient of 1 for x. This time I don't have any y's. I have a -5 for a z and a constant of 0. That's an augmented matrix. Okay, so the first part of your homework is just going to be, can you take a system in this form and put it in an augmented matrix? Can we do that? Okay. What is the main diagonal in this one? What numbers do you see in the main diagonal? 1, -1, and -5. Okay? All right. Go ahead and write an augmented matrix for this next one. All right, checking. First row, you should have 1, -4, 3, and 5. Second row, -1, 3, -1, -3. And third row, 2, 0, -4, and 6. Yes? Okay. What we're going to do with those augmented matrices is we're going to put it in what's called row echelon form. We abbreviate that REF. you will be expected to get a matrix into row echelon form without a calculator. There is another form called reduced row echelon. We'll look at that next week. That takes it a few steps beyond what row echelon is, and we'll use calculators most of the time for that. Okay? But for this first part, you are expected to do this without a calculator. So in row echelon form, what you're going to see is a system where your main diagonal are ones. Everything underneath it would be a 0. So we have nothing here, we have nothing here, we have nothing here. Okay? That's row echelon form. In a matrix format, it's going to look like that. So again, our main diagonal is 1, and everything underneath here is zeros. All right, so the rules for what makes something be in row echelon form. The first one says each first non-zero entry in every row must be a 1. In other words, as you look across a row, the very first number that's not 0 must be a 1. The second rule says each of those leading 1 entries is to the right of the one in the row above. In other words, as I move to the right, my 1 moves further to the right. As I move down, I should say, the 1 moves further to the right. Does that make sense? Okay. And then the last rule says if you have a row of all zeros, it has to be in the bottom, the last row of your matrix. So I'm going to pause the video for a minute. There's 6 examples here. I want you to go through as a group and decide, is this in row echelon or not? Does it fit these 3 criteria? Okay, going through each of these. The first one, is it in row echelon form?
Yes.
Yes. The first number that is not a 0 in every row is a 1. We don't have any completely 0 rows to worry about. And as we move down each row, our 1 moves further to the right. Yes? Okay. Looking at B, does that fit the criteria? No. Why not? Yeah, this row needs to be at the bottom. Okay, and we can move those. We'll talk about the operations we're allowed to do in a minute. How about C? I'm guessing a lot of people put no for that when you first looked at it. And usually what trips people up is the 1 here. You think it has to be here. Okay? The rule just says every row, the very first number that is not 0 has to be a 1. So the first number that's not 0 here is a 1, here's a 1, here's a 1, here's a 1. Everything else was zeros. Okay? Do your 1s move further to the right as you move down? Yes, they do. And we don't have any rows full of zeros to worry about? So this is a yes. How about D? That is a yes. Okay? Each row starts with a 1. You have a row of zeros, but it's at the bottom where it needs to be, and your 1s move to the right as you move down. For E,
No.
why not? The 2, right there. Okay? The very first number in that row that's not a 0 has to be a 1, not 2. All right? And the last one? Is that yes or no? Yes. Okay. So, what we are going to do with those, we are going to take an augmented matrix and get it into that row echelon form. All right? We want our main diagonal to be all 1s, and we want everything underneath to the left to be zeros. The operations we are allowed to do, we can interchange any 2 rows. So for example, if we have a row that has all zeros, we could move it to the bottom. Okay? The notation that you're going to give me would be something like this. Okay? We're going to interchange row 1 and row 2. The second thing we are allowed to do is multiply a row by a non-zero number. Maybe I want to multiply everything by a 2, or I want to multiply everything by a 1/3. I'm allowed to do that. An example, we just write 1/2 times row 3, something like that. And then the last thing that we're allowed to do, we can add a multiple of a row to another row. We can add a multiple of one row to a different row. So maybe I want to take -2 times row 1 and add it to row 2. I am going to require that you give me that notation, that you tell me what it is you're trying to do. When we solved a system using that addition multiplication method back in chapter 8, I had similar things, right? I told you, tell me that you're taking equation 1 and adding it to 2 times equation 2, right? That notation, you need to show me that, okay? Where students get mixed up in going from what we did in chapter 8 with the adding and multiplying method to this, we are not trying to make this matrix smaller. Before, when we had a system of 3 variables with 3 equations, we tried to get it down to 2 variables and 2 equations. Okay? We're not doing that. If we have a system of 3 equations, so our matrix has 3 rows to it, we're always going to have 3 rows. So it's important to pay attention to what row you are changing. I'm going to emphasize that as we go through these operations. For the first ones, I am going to give you steps. I'm going to tell you what operations to do. By the time we get to the last example today, you're going to have to come up with the steps. Okay? There is a very set process that you have to go through. Keep in mind, our goal is to have that main diagonal be 1s. And the numbers under here to be 0s. We don't care about all the other pieces. They can be whatever number they are. But that's what we need to get it into. That's row echelon form. Okay? So the first step here says we are going to multiply row 1 by -1, and we're going to add it to row 3. The row that we are changing is row 3. So we might multiply a row by something and add it to a different row. It's the row that we're adding it to that's changing. Okay? The process you have to go through is to get that first column to look like that before you try to deal with anything else. You have to get a 1 on top and 0s underneath it before we move to make row or column 2 the way we need it to be. Okay? If you don't do that, you're going to start undoing steps you've already done. Okay? So looking at this first step, they're telling me take -1 times this first row and add it to this row. Would that help me turn this into a 0? Yes? Okay. The row that we're changing is row 3. So I'm going to start out writing my matrix. Rows 1 and 2 I'm not doing anything to. I'm going to use row 1 to affect row 3, but I'm not changing row 1. So write out the first 2 rows. We are now going to take the first row, we're going to multiply it by a -1, and we're going to add it to row 3. So I'm multiplying this row by -1. -1 times 1, I'm going to add it to this row. So -1 plus 1 is 0. Multiplying 3 by -1 gets me -3. I'm adding it to 0. I now have a -3 there. Multiplying 0 by anything doesn't do anything. I'm adding it to -5, so I still have -5. Multiplying the 9 by a -1 makes -9. Adding it to 0 gets me -9. I like to put that dotted line in to separate the constants. You don't have to have it in there, but it does help you see the coefficients versus the constants a little easier. Is the first column the way I need it to be? Yes, I have a 1 on top and zeros underneath. Now I can move to the second column and try to manipulate that. I need for this to be just a regular 1, and I need for this to turn into a 0. Okay, that's the goal. Doesn't matter which of those two things I do first, but I have to do both of those before I move to work on column 3. Okay, so could we multiply row 2 by a -1 and get that to turn into a +1? Okay, so that's my next step. I'm changing row 2. So the first row I'm going to write down, that doesn't change. Row 3 doesn't change. All I'm doing is changing row 2. I'm multiplying through by a -1, so I end up with 0, +1, -4, and +2. Okay? We're getting closer. The next step they are giving me says take 3 times row 2 and add it to row 3. What is that going to do? In other words, why am I doing that step? Yes, I want to turn this -3 in the bottom row to be a 0. Okay? I am changing row 3. Circle that. That's the row we're changing. So rows 1 and 2, I'm going to rewrite. I'm not changing those at all in this step. Okay, we are now going to take our second row here. We're going to times it by a 3 and add it to that row. So 3 times 0 is still 0. Adding to 0 is still 0. 3 times the 1 makes it a 3. Adding with the -3 gets me a 0. The 3 times -4 gets me -12. I'm adding it to -5, so I'm at -17. And the 3 times the 2 gets me 6. Adding it with the -9 gets me -3. Okay? Is my second column done? Yes. The last thing I have to do is that -17 in the last row has to be turned into a 1. I can multiply by -1/17 to row 3 and turn that into a 1. Again, the other two rows have not changed. The bottom row timesing by anything to 0 still stays 0. My -17 multiplied by -1/17 becomes a 1. The -3 multiplied to -1/17 becomes 3/17. Have I put it in row echelon form? Okay. We're going to do that on this next one, and then we're going to talk about what we can do with it once we get it in that format. So the first step is to rewrite this as an augmented matrix. Again, we're using our coefficients. Remember to put zeros in for any missing ones. All right. The very first row starts with a 1, which is great. That's what I need. The next two things that I have to do is to make these two become zeros. Okay? Again, it doesn't matter which of the two I do first, but I have to get those two to be zeros before I move to the next column. Can I add rows 1 and 2 together to create a 0 for that first entry on row 2? Okay, so that's one of the steps they're telling me to do. Again, I could do that one first. I can do it second. Looking at what they're telling me to do here. 2 times row 1, and I'm going to subtract row 3. 2 times row 1, subtracting row 3. Will that get me a 0? Okay, I am going to change row 3. Is there another way I could have written that? Some people don't like to subtract. Could I have multiplied the top row by -2 and then added it? That's another option. Okay? We'll go with what they have listed here, but again, when you have to come up with your own options, if you don't like to subtract, you can do it that way. All right, so 2 times the first row, and then we're going to subtract row 3. I'm changing row 3, so I'm going to take a minute and get the other rows written down. All right, so 2 times the first row, 2 times 1 is 2, minus the 2 from the third row is 0. 2 times the -2 is -4, minus a -5. Think about that. -4 minus -5 is 1. Okay? 2 times 3 is 6, minus the 5 is 1. And 2 times the 9 is 18, minus 17 is 1. Okay? Our next step, we're going to add rows 1 and 2. Which row are we changing? Row 2. So I'm going to write row 1 and row 3 down. I'm going to alter row 2. If I add row 1 and row 2, 1 plus -1 is 0. -2 plus 3, 3 plus 0. 9 plus -4. Okay, is my first column done? Okay, I can move to my second column. Now, I already have a 1 as the first entry in row 2, okay, which is what I want. All I have to do is get this bottom row, this first one, to become a 0. So they listed the step as taking row 2 minus row 3. I also could have done -1 times row 2 and added it to row 3. Okay, that would work as well. We are changing which row? The third row. All right, so let's write down our first 2. All right, so row 2 minus row 3. 0 minus 0. 1 minus 1. 3 minus 1. 5 minus 1. Okay. Is my second column done? Yes. Now, my third column. I don't care about the first 2 entries, but the bottom one needs to be a 1. Can I multiply this bottom row, row 3, by 1/2 and turn that 2 into a 1? Okay. Sometimes multiplying by a fraction is going to create some fractions for you. In this case, both my numbers were even, so multiplying by 1/2 isn't going to do anything to create fractions. All right, so I'm multiplying through. 0 times anything is still 0. 2 times 1/2 is 1. 4 times 1/2 is 2. Did we get it into row echelon form? Okay, now, here's why we're doing that. Because once we get it into row echelon form, we can do something called back substitution. I want you to picture what equation would have been written from this augmented matrix. So my first line, I have 1 for my x coefficient. I have -2 for my y coefficient. I have 3 for my z coefficient. And it's supposed to equal a constant of 9. Okay? My second one says I have 1 y and 3 z's, and it's supposed to equal 5. And my bottom row says what? 1z equals 2. So I already have my first variable. If I know that z equals 2, can I substitute it back into that next equation? And then I can find y and substitute those back into the top one. Okay, that's why it's called back substitution. So we know z is 2. Let's plug it in. So y plus 3 times 2 equals 5. If I subtract that 6 to the other side, y has to be -1. Okay. Now I know z and y. I can plug them into my top equation. So I have x minus 2 times -1 plus 3 times 2 equals 9. So x plus 2 plus 6 is 9. What would x have to be? 2 plus 6 is 8. Subtracting 8, we get 1. So my solution to the system, x is 1, y is -1, and z was 2. Okay? Again, that's called back substitution. All right, so our last example today. You are going to help me come up with the steps that are needed to put it in row echelon form. Okay? So, step 1, rewrite it as a matrix. All right, so for this example, my augmented matrix should be 3, 1, 2, 31. 1, 1, 2, 19. 1, 3, 2, 25. My main goal is to get it into into row echelon form. All right, so I'm looking at the first column. My goal is to have the first column be 1, 0, 0. Yes? My very first number is a 3. Now, I could say I'm going to multiply that whole row by 1/3, but it's going to create a whole bunch of fractions for me in that row. And then I have to manipulate fractions to combine with other rows, and it gets messy. Do I have a different row that starts with a 1? I could do the second or the third. I could interchange either of those with my original row 1. Yes? Okay. So, first step we're going to do, we are going to swap, interchange row 1 and row 2. Okay? So, my new matrix, 1, 1, 2, 19 is now my first row. The 3, 1, 2, 31 is now my second row. And I haven't changed the third row. Now my goal is to try to make zeros for my first entries, so that 3 and that 1 we need to make become zeros. Again, it doesn't matter which one I do first. Okay? So let's say we're going to use row 1. What would we need to multiply it by to get that 3 to become a 0? Okay, so we are going to take negative 3 times row 1, and we're going to add it to row 2. All right, the new matrix I get. First of all, which row are we changing? Row 2. All right, so my first row stays the same. My third row stays the same. And we are going to change row 2. All right, so negative 3 times the 1 is negative 3. Adding it to that 3 gets me a 0. Negative 3 times this next one is negative 3. Adding it to the 1 here would be negative 2. Negative 3 times 2 is negative 6. Added with a 2 is negative 4. And negative 3 times the 19 is negative 57. And we're adding it to 31, which gets me negative 26. Okay? I'm still working on that first column, trying to get it to be a 1, 0, 0. So now I have to do something to get this 1 here to be a 0. What could I do? So I could take row 1 minus row 3. Could I also do negative 1 times row 1 and add it to row 3? Which do you prefer? You can do either way. Okay? Let's do negative 1 times row 1 and add it to row 3. So we're changing row 3. All right, so negative 1 times the first row added to the third row gets me a 0. Negative 1 times this 1 is negative 1. Added to 3 is 2. Negative 1 times the 2 added to 2 is 0. Negative 1 times 19. Negative 19 added with the 25 is 6. Is my first column done? Okay, now I move to the second column. What would happen if we add rows 2 and row 3? We get a 0 in the bottom, in that bottom row, and that's one of the things we're trying to get, right? So let's go ahead and do that. So let's take row 2 and add it to row 3, and we are changing row 3. All right, so row 2 plus row 3, 0 plus 0, negative 2 plus 2, negative 4 plus 0, negative 26 plus 6. All right. What do we have left to do? We need to change this negative 2 and make it into a 1. Yes? Could I multiply this row by a negative 1/2. Would that create a 1 there? All my numbers in the row are nice and even, so timesing by a 1/2 would be clean, no fractions. All right, so we are going to take negative 1/2 times row 2. So you should be getting 0, 1, 2, 13. Agree? Okay. Now, we're almost done. What do we have to do to get row 3, or column 3, sorry, to be right? And we don't talk about it as dividing by a negative 4, but same effect. Multiply by negative 1/4. Okay. So, negative 1/4 times row 3. Negative 1/4 times negative 4 is 1. Negative 1/4 times negative 20 is 5. Did we get it into row echelon form? Yes. Can we do our back substitution now to figure out our variables? Which one do we already know? We already know z is 5. Yes, 1z equals 5. Okay, we're going to back substitute it into that second row. What equation do you see with the 1, 2, 13? What does that mean? 1y, 2z's equals 13. So if we dump a 5 in there, we have y plus 10 equaling 13. So y would have to be 3. Okay. What does the top row tell me for an equation? X plus y plus 2z's equals 19. Okay, dumping our numbers in. We said y was 3, z was 5, so that makes it a 10. If we subtract the 13 over, we get x to be 6. So my solution would be 6, 3, 5. Okay, and just like any system, you could dump that back into the original equations and double check that it works. Okay? So, for your assignment, you're doing 1 through 18 and 21. 21 is the only one where you're doing this whole process. The other ones you're just writing an augmented matrix for it, or converting it back into a system of equations, or doing a single row operation each time. Okay? So, my suggestion would be to try number 21 right now, while it's fresh in your mind and you have your partners to help you.